Hello again, everyone. Welcome to our discussion of section 2.5, where we will wrap up our discussion of transformation of basic functions, quadratic functions, square root function, absolute value function, and so on. So what I thought would be best is to place some review material from the past lectures. So all this stuff that you see on the front page of this worksheet, which you already find on Canvas, is something you've seen before. So I thought it would be nice to just put those rules here as well. The main thing to remember is that the basic general function for the square root function is square root of x minus k, and then depending on what k is, then the horizontal shift is determined to the left or to the right. The horizontal shift would be to the right if this minus is preserved. If it becomes positive, then the horizontal shift is to the left, because that would indicate a positive x plus k would indicate that k must have been some negative number. So minus k would be this positive. And h on the outside of the square root function would indicate vertical translation along the y-axis. So either up when it's positive h or down when it's negative h. And with respect to the absolute value function, the basic general equation is that absolute value of x minus k, then depending on the value of k, if it's positive, then this minus is preserved. If k is negative, then we end up with x plus k. And k would determine, once again, just like the square root function, it would indicate the horizontal shift, whether to the left, in which case k would be negative, or to the right, if k is positive. And once again, h on the outside of the absolute value function would indicate up or down movement, depending on what the algebraic sign of that value is. So then, also with respect to the quadratic function, once again, the general equation is that. And then, of course, depending on the value of k, whether if k is positive, then this minus is preserved, so the horizontal shift is to the right. If this k is negative, then minus a negative number is positive, so the horizontal shift is to the left. Okay, and then h on the outside indicates transformation up if h is positive, down if h is negative. The same thing for the quadratic function, no different. Okay, so all of this is we've talked about before. So today we'll just do some additional exercises on transformation of functions. So just a reminder that any function x minus h plus k shifts the graph of f of x h units to the right and k units up. In this case, this term, because it's outside of the function, indicates vertical movement. So disregard that k. This k is not the same k here. This k is the same thing as h here. So if the point being, if any variable is outside of the function, it indicates vertical transformation, up or down, depending if it's positive, up, if it's negative, down. But the value of h, the value of the variable that is inside the function, inside the square root function, quadratic function, or absolute value function, determines the horizontal shift. Okay, so let's take a look at some of these, and maybe we'll double check with the computer. So we'll talk about it, and then I'll switch back and forth with the computer so you can see exactly what these transformations look like. So the first one, it says if f of x equals the quadratic function, that's the basic quadratic function, then g of x equals x plus 9 squared shifts the graph of f of x in which direction? What would you say? It would shift the graph of f of x to the left or right? to the left, right? 9 units to the left, or 9 units left, like that. So let's look at this on the computer. So I'm going to enter here, I'm going to enter y, or f of x, equals x squared, right? That's the basic quadratic function. Now the one we have is a transformation of that. So it is x plus 9 squared, right? So let me scroll over. So as you can see, this vertex, and as a result the whole function, the whole graph, moves 9 units to the left, which is what we determined. Okay, so this blue one is the transformation of the original function. Okay, so the next one, it says if the cubic function is f of x, then g of x equals x minus 4 cubed shifts the graph of f of x in which way? 4 units, right or left? Right. Okay, so let's look at this on the computer. So we have, in this case, we have cubic function, and then inside, so inside here we have minus 4, right? X minus 4 cubed. Okay, so let me scroll this over. As you can see, this vertex, or this whole, as a result, this whole function, this red one is the original cubic function. Now the blue one is after the transformation has occurred, which is x minus 4 cubed. Okay, so it's moved 4 units to the right. Okay. So the next one for us, it says if the absolute value function is the f of x function, then g of x function, how does g of x, like that, transform the original absolute value function? Well, we have x plus 5, so we have 5 units movement horizontal. In which direction? Left or right? So 5 units left, right? Because the general form is x minus k. So if you have plus 5, that means k must have been negative 5, which is movement to the left, 5 units. And then 3 units down, right? Because it's negative. 3 units down. Okay, so let's look at these on the computer. First, we have the absolute value function, absolute value of x, and I should get rid of that. And then this other function, which is g of x, or let's call it g of x equals absolute value of x plus 5 minus 3. So let's move this over. Right? So you can clearly see how the transformation has occurred. Take a look at this vertex, because along with the vertex, everything else has been moved, right? So this vertex was at 0, 0. That's for the f of x equals absolute value of x function. And then the blue one is the transformation. So we have 5 units movement to the left, right? Minus 2, minus 4. And this middle line is minus 5, so right there. And then a 3 unit drop. So this is negative 2, and then negative 3 is in between negative 2 and negative 4, right there. Okay, so if we plot that point, the coordinates of that point is, let's plot it, -5, comma, -3. And there, as soon as I entered the point, you can see that point snap to that. And I don't know if on the projection, this is light green coordinates are being shown. I hope you can see it in the video. I won't know if you can see the point until I look at the video later, but that's where it is. Okay, so let's switch back to the dock camera. Okay, so then we have the absolute value function is equal to, if it's transformed with the g of x function, absolute value of x minus 3 plus 2, how does this transform the absolute value function? Well, we have 3 units, horizontal shift, right? In which direction? To the right. To the right. And we have 2 units movement or transformation to up. 2 units up. Okay, so let's look at this on the computer. So the first one is the same. It's the absolute value function. I'm not going to erase that. But now we have g of x equals the absolute value of x minus 3. Oops, I need to fix that. So absolute value of x minus 3 plus 2. There. So what happened is we have 3 units movement to the right, right? Up to here is 2 units. Check how this vertex moved, because that indicates how the rest of the function moved. So this vertex moved from 0, 0 to 3, comma 0, and then it moved up 2 units, right? So if I label that point with 3, comma 2, right there, it snaps to it, right? And we can label it. So 3, comma 2, all right? Okay, so then the next function is the square root function here. Then the square root of x minus 7, how does that transform this function? Well, we have minus 7, so there is a horizontal shift to the right or left? To the right. So we have 7, a shift of 7 units right. And no shift vertically, right? There is no plus 5 or minus 3 outside here. All we have is this minus 7 on the inside. Okay, so let's look at that on the computer. So we have f of x, which is equal to square root of x, like that. So that's the main function. Now we have to transform that, right? We have to move that using this new function, which is g of x, which is equal to square root of x minus 3. Sorry, no, I was looking at another function. So square root of x minus 7. There. So we have 7 units. See, this vertex moved 7 units to the right, right? Like that. So if we plot that point, so let's say 7, comma 0, you can see that point appear at 7, comma 0. And let me label it with 7, comma 0. Okay, so let's go back to the dock camera. So number 6, here we have again a square root function as our original function. We want to transform it using the g of x function. So this transforms that function 3 units down. Okay. Let's do a few of these and then I'll go back to the computer. So we'll start with, when I go back to the computer, we'll start with number 6. Number 7, we have the square root function again. Now this g of x, which is that square root of x plus 3 plus 5, transforms that in which way? 3 units, is that 3 horizontal shift or vertical shift? It's horizontal shift, right? In which direction? Left or right? Left. And then the 5, up, right? Like that. Let's do this one, and then I'll go to the computer because the one after that is the quadratic function. So we have square root of x. We want to transform it using this g of x function minus, there's a minus in front of the square root function. So that indicates reflection of the original function across the x-axis. So we have reflection across the x-axis. We have that. And we also have something else going on here, right, with the 3. 3 units up. Okay, so let's now go back to the computer. We're going to plot 6, 7, and 8. Okay. So here, this is the original square root function. This is how the graph looks like. Now, the number 6 was square root of x, and then minus 3. So there. If you look at your notes, if you have them in front of you, right, we have 3 units movement down, right? -2 and -3 would be right there. So if I label that, it would be -3, 0, -3, right there. And let's label it like that. So that's that point. Okay. So let's go to plot number 7. Number 7 was square root of x plus 3 and then plus 5. All right? So there it is. They're both the same color. Let me try this. I want to change the color, so let me get rid of that. I don't know why it switched to the same color again. I want to distinguish the colors here. Oh, great. So it's now red. So this red one is the original one, and the black curve is the transformation. So this vertex, we can easily find or know what the coordinates of that is, right? Because it was moved from the origin, which is 0, 0, 0, 0, to -3, 3 units left and 5 units up. And there you have it. And we can label it like that. -3, 5. Okay. Okay, let's plot also number 8. So number 8 was minus. That's where we had the reflection going on, right? So minus square root of x. And then we have plus 3, like that. So the transformation is the green one. So watch what happens. This the curve, the original curve, square root of x, got reflected across the x-axis, and then the vertex was moved up 3 units. I mean, let me do this incrementally. So let me get rid of the plus 3 right there. So right now, with minus square root of x, we have perfect reflection across the x-axis, right? Like that. This curve, the red one, the original one, was reflected across the x-axis because of this minus in front of the square root function. Now we want to add 3 units. We want to move that plus 3, so plus 3. Okay, and then if you want, we can snap to it by saying 0, 3, which is that, and we can label it like that. Okay, I hope this is making sense. Okay, so number 9, which is next, is the quadratic function. So let me first, so that's the original quadratic function, but let me go back to the dock camera so you can see what's going on. Okay, so here, the quadratic function is transformed using the g of x function, which is x squared minus 2. So how does this shift occur? It's 2 units down, right? Minus 2. How about this one? Let's do this one before we go to the computer. This one, the shift is occurring 5 units horizontal, right? In which direction? 5 units to the right. And 3 units up. Right? Like that. So let's plot these two on the computer, number 9 and number 10. Okay, so for number 9, the g of x function was the quadratic function and then minus 2, right? So that vertex drops from 0, 0 to 0, comma, minus 2. So we can snap to it like that, that red dot, and then we can label it like that. Okay. Number 9, we had the original quadratic function shift according to this new function. We had x minus 5 squared plus 3, like that. Right? So we have, as we predicted, before we see this graph, we predicted that the movement would be 5 units to the right and 3 units up. In other words, if I do a point with 5, 3, right there, it snapped right to that vertex because the movement was after, the movement was from this vertex being at 0, 0. So we can also label it like that, 5, 0, 5, 3, right? Okay, so let's go back to the dot camera. All right, so now we're back to a square root function. Okay, let's do both 11 and 12 on paper before we go back to the computer. So we have the square root function, and we want to transform using this new function g. So we have 2 units of transformation. In which direction? It's horizontal because it's inside the square root function, and it's in the direction of left. 2 units left, right? And 3 units up or down? Down, right? And then this one, we have a lot going on here, guys. So we have this minus that is doing something, we have this plus 2 that is doing something, and then we have this plus 3 that is doing something. So let's write them all down here. So we have 2 units horizontal shift to the left because of this. 2 units left, And I'll just bullet these like that. And then because of this minus, we have reflection across the x-axis. Sometimes you read reflection in the x-axis or across the x-axis. And then because of this 3, we have 3 units movement in which direction? Up or down? Up. Right? Okay, so let's go back to the computer. We're going to plot number 11, that one, and number 12. Is this square root function? Okay, right? That's the basic square root function. And then number 11, we had to transform it using another function, g of x equals square root of x plus 2. And then on the outside, we have minus 3. So there you have it. We have 2 units shift to the left, right, from 0 to negative 2 right there, and 3 units movement down. So that vertex right there, the transformed vertex, has to be at negative 2 comma negative 3 right there. Okay, that's that point. Okay, number 12. Number 12, the square root function was transformed according to this one. 3 minus square root of x plus 2. Right? A lot is happening as we expected. So first of all, we have 2 units movement as a horizontal shift to the left. That's where you see that go from 0, 0 to all of a sudden negative 2 comma some value, some y value. What is that y value? It's the 3. So if you snap a point to it, we get negative 2 comma 3. And let's label it with that. So notice that it's an upside down curve, right? It's because of this minus that you see right there. So if I change that to positive, if I change that to 3 plus, watch what happens right there. Then you don't have the upside down, which is the reflection across the x-axis, right? But as soon as I change it to negative, it flips. It flips in the direction of the x-axis. But of course, it was moved, right? It was moved because of this. The vertex was moved 2 units to the left and 3 units up. Okay, I hope this is making sense as we are going through it. Okay, so let's go back to the dock camera. So now next we have the absolute value function. In which way the g of x transforms that? We can easily write that up, right? We have 2 units. 2 units shift in which direction? Left, right? And 7 units up, right? So let's take a look at it. So do we have the absolute value function like that? That's the graph of that. That's with no transformation, right? Now there comes along g of x function, and it wants to transform that according to this. Absolute value of x plus 2 and then plus 7. Okay, so it's way up there. It's the green one, right? So there was a 2 unit movement that happened to the left, and then 7 unit movement upward, right? So so what's the coordinates of that vertex, the transformed vertex right there? So we can easily snap to it by saying minus 2 comma 7. right? Right, that dot that you see, and let's label it like that. Okay. All right. So we go back to the dot camera. Next one, number 14, is a quadratic function. And again, there's a lot that is happening here. So let's prepare a bullet list here. So first thing is we have a 1 unit shift. In which direction? It's going to be horizontal, but in which direction? Left or right? So 1 unit left, right, right. Right? That's that. Then we have flipping across the x-axis because of this minus. So we have reflection across the x-axis, right? Then we have this 3. If it's 1, and I will say more about this on the computer, if this coefficient on the in front of the quadratic term, this whole parenthesis is quadratic term, right? This whole is being squared. I mean, the quadratic term is in there. Now, the coefficient of the quadratic term, if it's something between 0 and 1, we have a flattening of the curve. Again, if that number is between 0 and 1, it doesn't matter if it's negative or positive, but if it's between 0 and 1, this number, then we have a flattening of the curve. But if it's anything greater than 1, which is in this case, we have a stretching. We have the stretching of the quadratic graph, the arms of the quadratic graph get stretched and the whole graph becomes sharper, and the arms get stretched towards the y-axis. Okay, so we have reflection across the x-axis, and then we have stretching, not flattening, right? Because flattening would occur if this number was between 0 and 1. But if it's greater than 1, we have stretching along the y-axis due to positive 3 coefficient. And then, of course, we have this 4. So we have 4 units up. So there's a lot that is happening, right? So let's go back to the computer for number 14. So our original function is the quadratic function, right? We want to transform this according to this g of x function that is equals 4 minus 3 times x minus 1 squared. Notice this reflection across the x-axis means the flipping. The flipping of the graph is the same thing as saying reflected across the x-axis for this curve. And then take a look at the 1 unit movement to the right. Because of this minus 1, we have 1 unit movement to the right. So 0 to 2, and this vertex moved halfway in between, so it's at 1. And there was a 4 unit movement up, so if I snap a point to it, it'll be 1, 4. Oops, my number parentheses right there. And let's label it, so that's 1, 4. Then the main thing I wanted to talk about is the impact of this number 3. This number that is in front of the parentheses. Let's call it k, right? It made it disappear. So it says add slider. Should see maybe. Yeah, we can use this slider here, but I don't know if it's that clear. So let me know. I don't think adding the slider is helping. So I'll go back to the numbers. So if that number in front is something between 0 and 1, let's say 0.05, something really small, 0.05, right? Watch what happened to the curve. It's the same curve, but look how flat it is now. It's flipped upside down, of course, because of this minus in front. Because we have 4 minus, it's flipped up and down. If you want me to make it positive, right there. So it's now 4 plus, and it's right side up, but still, take a look at how flat it has become. That's the effect of that number, 0.05, right? So if the coefficient of the quadratic term is something between 0 and 1, you're going to have this flattening effect. But if that number is greater than 1, let me say something easy, say 2, right? Notice how much narrower, how much sharper this transformed curve is, right? It's sharper and narrower because the arms got stretched, got pulled, stretched toward the y-axis. So let me increase that. Let me increase it to 3, which is what we have. See, it's even narrower. Let me increase it to 20, and you'll see how sharp that curve will get, like that. Right? 30. Let's increase it. Look at that. Okay? And let's all of a sudden jump to 0.02. Look how flat it is. Right? So I hope you can see the difference between what this coefficient out in front of the parentheses will do if it's between 0 and 1, and if it's greater than 1. Okay? Okay, so number 15, we have the absolute value function that is being transformed using the g of x function. In which way? So we have 5 units horizontal movement, right? In which direction? Right or left? Right. 6 units, up or down? Up. Right? We can take a look at that on the computer. So let me change this to the absolute value function. Right? That's the original absolute value function. Now g of x comes along and transforms it using this absolute value of x minus 5 plus 6. Right there. So we have movement 5 units to the right, as we predicted, like that. That point has been moved halfway between 4 and 6, which is 5. And then 6 units up, right? So let's snap a point to that vertex. That would be 5, 6, right? That red dot that you see, and let's label it 5, 6. Okay, like that. All right. Now, number 16 and 17 on this worksheet for section 2.5, it's a little bit different than what we've been doing. It's saying, given this function f of x, find the function g of x such that f of x is shifted 8 units to the right, just 8 units to the right. So at this point, I strongly encourage you to pause the video for numbers 16 and 17. You can see them both on the screen now. For both of these, pause the video, write down your own answer on the paper, then come back to the video. Okay, I'm counting on you that you did that. Now you have your own answers. So g of x would be shifted 8 units to the right. That would be 3rd root of x plus minus 8, sorry. It's to the right. So this is minus 8. Okay, that's that. And number 17, we have the quadratic function, and we want it moved or transformed or shifted 8 units to the left and reflected in the x-axis. So g of x would have to be minus, right? Because we have reflection in the x-axis, so minus, and we have 8 units shift to the left, so plus 8 squared, because it's the quadratic function that we are transforming. So minus x plus 8 squared. Okay, I hope these answers match what you already have on your own paper. Okay, so having said that, we have come to the conclusion of this worksheet. Thank you for persisting along this video. Have a nice day, and I'll see you next time.